In this session we're going to talk about dimension items. Dimension items are the building blocks of a reaction plan. How they are configured determines how the data is analyzed and the instructions the operator sees. When the data collector reads and filters new part data, it opens the appropriate reaction plan and pumps data to the dimension items stored in the plan. Each dimension item is designed to hold a certain number of dimensions. As new data enters, old data drops off. Statistic calculations are performed, and the results compared to a list of rules to determine the appropriate instructions. If you are not familiar with reaction plans or the data collector, view the Reaction Plan Manager ++ solution video and how to build a Reaction Plan Manager ++ solution. In this example, one dimension item is included in the project. The dimension item is configured to show the detailed view. As the name implies, the detailed view shows all the detail. This type of configuration makes it easy to see how the data flows to the dimension item and understand its contents. The dimension item name is here. In this case, it's Tool 1. To the right of that is the operator instruction. In this case, there are no adjustments required. The dim info, short for dimension information, represents the type of tolerance for the data, plus and minus tolerances, and other information related to targeting. The process info, short for process information, represents all the data collected in the dimension. This type of information is valuable to evaluate data over a long period of time. The last run info, short for last run information, represents the latest dimensions added. It's a much smaller group and will react quickly to process changes. You can specify different reactions based on process information versus last run information. And to the right, you have a plot of the dimension item. Here I can see all the points, which represents the process info, or I could also just see the last run info points, which is at the top, these blue dots here. If I move my mouse over this arrow here, this is the last run average. If I move my cursor at this arrow, this is the process average, just showing you the average of all the parts versus the average for the last run info. The little target here represents where you're targeting the data to. In this case, the target is equal to the nominal location, which is 4. I'm going to use a data simulator to actually generate some data and pump it into this dimension item. That way you can see what it looks like as the data flows through it. I'm going to move this off the screen so you can't see it. Now if I click on the Inspect button, you'll see data flowing into the dimensional item. Notice that the number of parts for the last run info hasn't changed. It's still set to 3, but the statistics are changing based upon the data flowing into it. Also notice the process info. The number of parts is just growing, getting bigger and bigger and bigger. Eventually, you're going to reach a point where the number of parts will exceed the limit for the process info. When that occurs, the old parts will drop off the bottom and the new parts will just keep on flowing into the top. The process info and the last run info of the number of parts being evaluated in each case is configurable item, so you can set it up to any number that you wish. Now here notice the last run info is triggered a reaction. It's reached a percent of tolerance location, which is, I think it's set to 80%. That triggered a rule violation, an exception. So we're getting an instruction here which says adjust by minus 0.0051, which is how much you need to correct to retarget your process. Notice the process info hasn't reached that position yet because it's looking at all the parts, not just the last 3. To configure a dimension item, it's really pretty easy. I'll switch to the edit mode and then select the dimension item I want to edit. On the right hand side, a series of selections appear organized in tabs that'll let me configure the dimension item. You'll fill out the entries and then click on the Save Changes button down at the bottom to accept the changes and save them. Items included in the General tab include the name of the dimensional item, we call it the feature name, the default message when no rules are violated, the startup graphics view. Here you have 4 choices. I can choose from detail, condensed, summary, or none. If I've got the startup graphics view set to none, what will happen is you'll just see the operator message with no graphics. I can include I can do a process reset. I can include a button which will actually reset the part counter to 0. This is useful if you make an adjustment. If I make an adjustment on a machine, clearly I want the data to start from 0, start from scratch. So if I check this box to display process reset button when rule is broken, it will reset the part counter. It'll display a button where the operator can click on to reset the part counter. And I'll put a message in here of something like press button if adjustment made. I can also reset the part counter on all of the objects, all of the dimensional items in the reaction plan when the operator hits the button. This is useful if the adjustment affects all the dimensional items. You can also include a leader. The leader really pertains to the detailed view. I haven't really talked about that. Right now I'm going to have this set to single so that a leader will be displayed when I'm in the detailed view. The nominal/tolerance limits tab lets you identify the type of data being analyzed and where the data is located. So in this case, the tolerance mode is set to bilateral. You have 3 choices: bilateral, unilateral, and max and min. A unilateral tolerance, you only have a plus tolerance value. Max and min, you have a maximum limit and a minimum limit. We're going to leave this set to bilateral. Here you identify the column containing the data. If you want, you can identify pull the nominal, plus tolerance, and minus tolerance values out of the table. So in this case, the nominal cell is in B2, the plus tolerance cell is in B3, the minus tolerance cell is in B4. Notice to the right of each one of these entries, you've got the corresponding number that's pulled from the table. If you don't have that information in your data set, you can simply manually enter the values over here on the right hand side. You don't have to pull the values from the table. In that situation, you want to leave these entries blank. The target shift gives you a way to move the target to something other than the nominal target. So in this case, let's say I want to move shift the nominal target by 3 thousandths. So if I can enter a value here, and what that will do is it'll shift it from 4 to 4.003. The last run reaction tab includes entries to set up and analyze the last run information. The first entry is a number of parts to calculate last run statistics. Here I've got a value of 3. The last run correction multiplier is a value which will be multiplied by the calculated deviation from nominal. So if I put in a value of 0.5, that'll knock the value in half. So if my deviation from nominal average is 5 thousandths, for example, what will be displayed to the operator will be a value of 0.0025. The rest of the entries below this involve the rules. You've got the standard deviation rule, range rule, percent of tolerance rule, and out of tolerance rule. Notice they are color coded. To the colors represent the severity levels. Red, of course, is critical. Yellow is warning. The standard deviation rule. The last run standard deviation is beyond the standard deviation limit. So here you could put in a value which represents the standard deviation. So for example, if I put in a value of 0.003, that'd be 0.003 standard deviations. If the calculated standard deviation is beyond that, this message will appear. And the message might be something like contact engineering. Standard deviation rule violation. The range rule is similar. Now instead of calculating looking at the standard deviation, it's now going to look at the range. I'll put in a value of, I don't know, I'm just making these numbers up, 0.004. And maybe I might have a similar type of a message. Range rule violation. Contact engineering. The percent of tolerance rule, as the name implies, is a percentage of the tolerance. So you can put in an upper tolerance value, upper percentage of tolerance value, or a lower percent of tolerance value, and a lower percent of tolerance value. They don't have to necessarily be the same. You can mix them up based upon your process and how you want to influence the adjustments. The message for the standard deviation, or I'm sorry, the message for the percent of tolerance rule violation is basically just tell the guy to make an adjustment, tell the operator to make an adjustment. Here you'll notice I've got this text here. This really is a variable, and what will happen is if this rule is violated and this message appears, it'll say adjust by, and then it'll give you the last run correction value. The out of tolerance rule is similar. You know, if the average is beyond the tolerance limits, it'll violate this rule, and this message will appear, adjust by, and then it'll be the value of the correction, the last run correction amount. The process reaction tab includes entries to set up and analyze the process information. The first entry is the maximum number of parts to calculate process statistics. This actually represents the number of parts in the dimensional item. So here I've got a value of 30. The next entry is the minimum number of parts before monitoring standard deviation spread. Here we have a value of 30 as well. Clearly you don't want this number to be too small, because then the accuracy of your standard deviation is it's not quite as accurate. The number of standard deviations on each side of average used to calculate standard deviation spread. The value here is 0. If it's 0, it'll ignore these rule violations. So I'll put in a value here of 3. This will be plus or minus 3 sigma. The process correction multiplier is a multiplier that'll be applied to the deviation from nominal, the average deviation from nominal. This value will be multiplied times that value and displayed to the operator. The next two entries are the actual rules: the standard deviation spread rule and the standard deviation to average rule. The standard deviation spread rule is the standard deviation spread is greater than the tolerance spread, then this message would apply. So this is like this the CP ratio. So in this case I would put something like contact engineering. CP rule violation. The next one is standard deviation to average rule. This is the standard deviation spread relative to the average is beyond the upper or lower tolerance limit, then this message would apply. This would really be your CPK ratio. Now, if your CPK ratio is bad, you might be able to adjust your way out of it to fix the problem. So we may want to put an adjustment instruction here. And then I'll hit this button to insert the process correction message. Notice that it inserted this text into this message body. Again, this is a variable, so the process correction value will appear here in this message if this rule is violated. When you're finished configuring your dimension item, you click on the Save Changes button. That'll save whatever modifications you made to the dimension item. Now I'm going to go ahead and go to the View mode. I'm going to save this reaction plan. Click on the A plan. Now notice we have a button which says Press button if adjustment made. We've got our target now is no longer the nominal. It's shifted by 0.003. Our last run correction value is minus 0.0011. That would be the difference from the last run average to the target, and it's been divided by 2 because we've got a 0.5 correction multiplier applied to that. The same thing with the process correction. We've got a 0.5 multiplier assigned to that as well. So our process correction is half, half of what it would be from here to our target. Now, since we have a rule violation, we've got a percent of tolerance rule violation. This button appears. So if I click on this button, it'll reset my part counter. Let's go ahead and click on that. Notice it turns green. No adjustments required. You see this blue line? That blue line is letting you know that the part counter was reset to 0. So if I were to apply new data, watch what happens. You can see we're pretty much starting over again. Let's pump some more data in here. And you get the idea. I'm going to go back to the edit mode. When we made changes to this dimension item, the changes were applied to all of the reaction plans. So this one dimension item in the template plan, machine C, machine B, machine A, all of them were affected. Now if I click on machine A and click on this dimension item, you'll notice I've got my normal tabs: general, nominal, tolerance, last run reaction, and process reaction. But you also notice I've got 2 new tabs: advanced message overrides and advanced output. Anytime you see the word advanced, that means whatever you do is going to be applied to this one particular reaction plan. So if I make changes here to the message overrides, for example, it will only be applied to machine A as opposed to all the other plans. Message overrides, as the name implies, are ways to override the default messages for the rule violations. Advanced output is a way you can actually generate data files when a reaction occurs, and this defines the content of the data that gets written to the data file. This will be discussed more in another topic, how to generate data files and that type of stuff. To complete this solution, simply insert and configure the dimension items as needed to analyze the data. In this session you learned about dimension items, the building blocks of a solution. You understand how they work and how to configure them. Thank you.